Hello, everybody. Thank you guys so much for attending Bias and Algorithms and AI. My name is AP Anderson. I'm a research and instruction librarian at Velma K. Waters Library. I am the subject liaison for the sciences. I am a member of TAMUC's AI initiative, and this is also just an area of personal research interest for me, but I'm coming at this from the point of view of a librarian, somebody who studies information, the way that people use it, the way that they evaluate it, how it is created, and how it goes on to inform our lives. So that is the information sciences perspective that I'm bringing to this as a presenter. Now, without any further ado, I am going to go ahead and get my face off screen, and we're going to go ahead and get started. Just to briefly brush over what we're going to be talking about, we're going to be discussing different biases that can appear in algorithms and AI systems. We're going to be talking about how those are introduced into those systems, and we're going to be talking a bit about how these biases impact use cases in terms of potential for harm. I wanted to give a note on the sources that I'm going to be using in this presentation. A lot of the times in the sciences in particular, there is a priority for the most recent sources as being the most relevant. Some of the sources, as you'll see here in a minute, are things that are referring to older problems. And the reason that I have included these, even if they are on a non-current version of a software that is still available today, is because they're indicative of patterns that pop up with algorithms and AI. And even in the case of like something being a problem in ChatGPT 2 versus the models that we have now, OpenAI did not scrape out their entire data set, throw it out, and build it from scratch when they released 3.5 over 3. Issues of remediation are ongoing. New problems are being discovered all the time. And so I am including some of these examples, even in cases where remediation has been somewhat successful, to show that this is a pattern. And these are things that we've been talking about in the field for a very long time. And by a very long time, I do mean way longer than ChatGPT and similar technologies have been on the market. In 1982 up until 1986, there was a medical school in the United Kingdom that was using an admission algorithm. It was cutting edge technology at the time, and it was pitched to the university as a way to expedite the admissions process, make it more efficient and labor saving, and also make it fairer. But in the audit of it that happened later, it was discovered that the algorithm was discriminating against women and applicants with non-Caucasian sounding names. Also, people whose country of origin and birthplace were outside of the UK were being weighted down. And that was not a machine learning system. I'll get on to the difference between those two in a moment. But it just goes to show that this has been an issue from the very start. These algorithms and AI systems are reflective of the societies and times in which they are made, and biases that are found in them can end up being replicated and baked in. And one of the things that I wanted to pull out was a quote from this article. Part of the problem was that it was believed that this computer was incapable of bias, that it was fairer than the humans that had been also dealing with issues of bias in their admissions program. And so a lot of people that were interacting with it took its word essentially as gospel and assumed that it was doing things as fairly as possible because a computer can't be biased. And that is a dangerous, pervasive misnomer. And I hope that by the end of this presentation today, I'll go on to show how that is the case. So moving onward, I want to talk about some terminology, just so that we're all on the same page about this, to differentiate between artificial intelligence and an algorithm. They are related concepts. An algorithm is a way of solving a problem. It is a series of steps. It isn't necessarily learning. That is when the artificial intelligence comes in. These are programs made out of algorithms that are able to learn from training data that they are given. They're able to observe patterns, and then they are able to take those patterns and use them to solve new problems. And that behavior emerges from how they run, what they experience, and the patterns they observe. Gen AI and LLM are two terms that will also get used a lot in this. Generative artificial intelligence, or Gen AI, These are tools that are creating original output based on the rules that they have learned. These are things like generators that can make art or photographs based off of their data set. This is things like ChatGPT, the music AI generators that are able to create songs. I'm not limiting myself just to these, even though they are something that is really prevalent in higher education. I'm also going to talk about other AI and algorithms that are in other fields that are not generating new content, but are learning. So things that have applications in policing, things that have applications in medicine and law. On that note, a large language model, it's the backbone of a lot of these tools, however they're being used. A large language model is trained on truly massive amounts of data. Oftentimes, these are scraped from the internet. They're trained on huge volumes of raw data so that they can observe those patterns and learn to replicate the kind of data that is in that. And if you are interacting with ChatGPT, the part of it that you are talking to is the user interface layer. But in the background, there is this large language model that was trained on essentially the entire internet. And it's making its predictions in the back, figuring out what word comes next in the sentence. And then that is what you get as output. And the reason that I'm branching out into other things other than generative artificial intelligence is that LLMs are where a lot of the issues with bias end up originating, and LLMs are in the background of other kinds of artificial intelligence as well. So let's go on ahead and move forward. Bias. So I've taken this definition from Oxford University's Dictionary of Media and Communication, and I like it because it does specify that bias can be conscious or unconscious, and it can manifest in behavior as discrimination, but it does not have to. And then I wanted to draw your attention to some other ways that bias can be expressed. When we are talking about bias in an algorithm or a generative AI tool or an LLM, sometimes this manifests as a generative tool generating hate speech. Sometimes it manifests as an art generator generating a racist caricature. That is stuff that is on the overt and explicit side of bias. But a lot of the times it is more of the implicit or covert, where it is prioritizing different parts of the decision-making process without necessarily directly saying it is because of race, gender, or another protected characteristic. Inequality of the people involved, the input involved, but those decisions are still favoring one group over another. And these biases can also be found in our systems and institutions and remain there rooted for generations. And when you have a machine that is trained to pick up patterns and learn from them, oftentimes it picks up on patterns that we wish it wouldn't. Historical injustices, patterns of discrimination, and it adds those into its learning. And I did want to note that bias is not limited to just one culture, place, type of person. It's different everywhere. And so a system that is designed in the United States by people from the United States on training data largely from the United States is probably going to have some baked-in biases that are specific to the United States, but it might also have things from other places. But efforts at remediating it have to take into account that it's experienced differently everywhere. This article that I've cited on this slide is talking about artificial intelligence and the caste system in India. You have to be aware of the fact that those biases are going to be different than ones that typically an American audience would be aware of. And so they can kind of fly under the radar without anybody realizing that this is something that is biased. I want to talk about a few examples of how these manifest in data. So first of all, selection bias, and all of these articles that I'm citing here are direct examples of this happening either in lab conditions or in the wild. Selection bias is when the data is different or more limited than reality. The example here is talking about a hiring algorithm that was developed by Amazon that was meant to be an early level screening thing to get people's CVs and cover letters past that initial hurdle so that just the best resumes would see people like actual human eyes and kind of exclude other people that are obviously not qualified. And it was trained on prior data about what a good Amazon employee is like. And they basically were like, go find us people like we have been hiring already, which is a problem given that they were hiring predominantly men. And so the algorithm was excluding resumes by women just because it had learned Amazon does not tend to hire those. And so they ended up scrapping that before it ever went into practice outside of the testing stage. After that, we have confirmation bias, which is where beliefs and trends in the data just kind of are allowed to perpetuate. And then we see them happening again and again, and we're like, oh, it's always been this way. The example here, so the specific advising software that is being used here in the Feathers article, that was identifying race as a high risk factor for whether or not students were going to drop out, which led to advisors sometimes encouraging students of color towards easier majors relative to things that were considered more difficult. That's EAB Navigate. That's something that we use on our campus. I'm unsure if we are using it in this capacity. EAB Navigate is a massive software that has applications all across campus outside of just advising. And even within their advising portal, they kind of leave it up to the individual school what demographic factors are weighted and how. But this 2021 article did identify that as one of the factors that schools could use to find students that were in need of extra intervention early on to make sure that they were not dropping out. And it was predominantly weighted towards students of color. Stereotyping bias is just what it says. It's when a model learns patterns based on something that is an existing harmful stereotype. The AI chatbot in question in that first article is ChatGPT 3, the version of it immediately before the version that released to the public for full release 3.5. The researchers found that due to the training data and the patterns that it had learned from it, it was creating content particularly associating Muslim people with violence at a rate that it was difficult for the researchers to create content that was not making that link. The link with Jewish people and money was also there, but it was difficult for them to de-link that. They had to actually like work in how they were prompting it to specify, like, please tell me positive things about Muslim people. And then measurement bias, which is the idea that you are measuring one thing in a way that it's not supposed to be measured. This was another situation where an algorithm it had learned a rule that was efficient as far as the machine was concerned, but it was not checked in with reality in terms of the people that it was meant to serve. It was intended to help healthcare practitioners identify patients that would need additional follow-up care, but instead of using anything related to their actual medical needs, it had learned that demographic healthcare spending data was a predictor of how much care people actually needed. And so white patients were far more likely to be recommended additional follow-up care than patients of color, just because demographically speaking, income levels and access to healthcare and access to health insurance and all of these other factors meant that as a demographic, white people spent more money on healthcare than anybody else. And then finally, we have outgroup homogeneity bias. If your data set looks very similar and you do not have very many people that are outside of that norm or categories or objects or whatever it is in the data set, it is less able to distinguish between things that are to the data set unusual, and they kind of get grouped together as all one thing. Whereas if you have a much bigger representation in the data set, it's able to determine the differences between those much more easily. This was a situation during the pandemic where students were required to use a exam proctoring software with facial recognition capabilities, and students of color were not seen on camera. The facial recognition software had a difficult time differentiating Black students' faces from the background, and they were getting flagged for testing irregularities for not having a person in the room during their exam. And then there's also, finally, not directly a type of bias, but a way that bias manifests. If there is a small bias in a data set, there can be a tendency for those models to make it more prevalent once it learns rules and builds upon them and codifies it into the system. This is not solely a problem of what is in the training data so much as it is how those rules are learned and how things are weighted within the system. So let's get into how the bias shows up. Training data is the obvious starting point for this. Depending on where the training data is sourced, there might be a scrape of the internet where all of this is coming from, pulling from social media and other sources where people's chatter is becoming the large language model's understanding of what human speech sounds like. But then you also have what is not included in a training data set side of it. So if you're only scraping the English speaking internet, it isn't going to learn as much about anybody that is not speaking English. And I wanted to call attention to this last point, the idea of a black box model. Sometimes the learning and the outcomes are not directly linked to whatever pieces of data are where that rule was observed. And this is even like in the case of the researchers, they might not know how the model arrived at that conclusion. And this is often the case in situations with like an LLM. They have such a huge volume of data that went into their training corpus that no human being is able to know everything that is in it. If it's a scrape of the entire internet to date, there are going to be things in there that, the researchers have not seen. And so there are connections that are being made on the back end that can be unexpected relative to the output that is being produced in the end. A couple of examples of this. So again, we talked about the facial recognition software for the testing software earlier. This can become a problem in other ways too, other than just not seeing people. There have been situations where facial recognition and facial identification software that does not have a lot of different pictures of Black people in it will get Black people confused for each other, identifying along gender lines, misgendering people. And in that last case, there was a very unfortunate tendency of that specific image classification model to take pictures of Black people and identify them as animals. And this is a problem of just who is in the data set and who is not. And then we also have the fact that sometimes there are some really heinous things on the internet. There are some people with some truly terrible opinions of each other, and that can end up kind of filtered into a data set and can be used to inform how that system learns. There's also the problem that even if you are trying to weed out the biased content, weed out examples of prejudice and bigotry, that attempt is going to be informed by its designer's idea of what is appropriate. I have more on that later, but it can end up being that the toxicity removal procedures end up being fairly toxic themselves. Next, we have data labeling. This is kind of an intermediary stage between when you have the data set and when the machine starts actually making decisions based off of it. There is a lot of work that goes on into making a large corpus of data meaningful. In the case of image labeling, as we mentioned earlier, this is somebody, either a real person, another AI tool, or a human working in conjunction with an AI or an algorithm, labeling every picture or part of a picture. This is like CAPTCHA, going in and saying which of these images contain a crosswalk or a bicycle. This is a large language model having somebody go through and read a bunch of sentences and determine if this is positive, if this is negative, if this is hostile. And this happens in iterative stages over and over again through the development of an AI tool, but it's subjective. Is this dress blue and black, or is this dress yellow and white? Is this sarcasm? Is this a joke? Or is this person actually being hostile? And so you can end up with bias creeping in at that stage in terms of how things are labeled and how things are interpreted, whose framework is being used to put things in different categories. And so a few examples. If you have image labeling that is being done and you have a bunch of pictures of people and you are saying, tell me if this person is male or female, and those are the only options and the only boxes that you're allowed to put things in, there are a lot of trans and non-binary people whose identities and whose images are going to be mislabeled. The same is true with large language models that have a hard time processing singular they, them as a pronoun. And so this is a situation where if your experience is in the margins relative to wider societies, the tool isn't going to necessarily know what to do with that. These tools aim towards the middle and the average and kind of exclude things that are on the margins. And then going on further, you have the idea of facial recognition and emotion detection technologies reading the planes and bones of your face to try to figure things out about you. Like, again, is this a man or a woman that I'm looking at? Is this person happy or sad? Is this person trustworthy? And again, these are very subjective rulings in a lot of cases, with a person's identity and internal feelings being read by a machine. And in some cases, like particularly in the case of determining the trustworthiness of whether somebody's lying, based on a facial expression or the way that their facial geometry is working. There have been scholars that have likened this to phrenology, the discredited pseudoscience that is linked with eugenics and race science, where people believed that you could determine a person's character and intellect by the shape of the bones of their skull. And I did want to say I'm not ragging on people that are doing the work of data labeling. In a lot of cases, this is work that is being done by task workers who are not paid well for this and who are in situations where they are having to label a lot of things very quickly with unclear rules that change frequently as the programming needs of the project change. This article interviewing several people that have done data labor work for AI companies, interviewed people around the world and what their job conditions were like. A lot of them were deliberately denied context for what their jobs were and why they were labeling these things as a way of these companies kind of protecting themselves against people infringing on what they were doing in the early stages. Curiously enough, one of the people interviewed was in Texas. She was doing some of the more late stage data labeling and classification of speech and was having conversations with a chatbot. And she was not told who she was working for, but she was able to get the information by asking the chatbot to tell her about it. That isn't related to bias, but I thought that that was a wild working condition that she was laboring under. So moving onwards a little bit, then finally we have to the pattern learning stage. So you have a meaningful corpus of data that has labels ascribed to it, and now the machine is going to observe patterns and replicate them. And I think that it is important to specify here that when we're talking about artificial intelligence, we're not talking about a machine that is thinking like a person. This is not true intelligence. This is not an individual with a consciousness as we understand it. It's a machine that's looking for the most efficient way to replicate a pattern, at least with the technology that we have now. And sometimes the rules that they will develop for maximum efficiency are things that do not make any sense from a human perspective, like the idea that how much a demographic spends on healthcare is actually something that one-to-one tracks with how much care they need. That's not something that like a person would think of if they understand anything about how anything works. One of the earliest examples I saw of this was a skin cancer detection AI that learned to be really, really good at picking out pictures of malignant skin cancer because it learned that from the training data set, there was usually a ruler next to the lesion if it was malignant, because if it was benign, you're not measuring it. And so it kind of shortcut to some crazy levels of efficiency, but not in a way that was actually useful. And so that is something to keep in mind. And also the fact that even after a system is deployed and in the wild, if it is a machine learning system, it's going to keep learning the more that it interacts with people and the more it is used. I keep coming back to image tagging just because it's got some very salient examples. But there are image tagging algorithms used in kind of training data sets for machine learning systems that are doing this automatic gender labeling. And researchers have found that some of them are taking the background of the image into account when assigning gender. And that in cases where the subject of the photograph is pictured in an unexpected environment compared to the trends in its data set, they have a harder time predicting what the gender of that person is, aside from all of the problems with predicting gender based off of what someone looks like anyway. But they were saying that they were getting tripped up by pictures of women in mechanics garages and men in kindergarten classrooms, because those are not the patterns that these tools learned for where these types of people are typically pictured. And then this last one here, even when you are attempting to mitigate the bias, it can have unintended consequences. This was something from earlier this year. Google's Gemini image generator had some problems. It was intended to be less biased than other image generators that have kind of a problem of generating the same kind of face over and over and over again. And so it was generating a range of faces to try to be more equitable, but it was creating content that is ahistorical and not something anyone in the entire world was happy about, including like racially diverse Nazi soldiers. And so that was a situation where the output, the ultimate conclusion, was off relative to the intention. So let's get into some potential harms. I am going to be leaning on some categories of potential harms that are identified by a couple of existing sources. The National Institute of Standards and Technology has recently put out a really good guide to responsible AI. I've linked to that at the end, but then those categories are also built upon from other sources. These are just a few of the categories. The type of risk and the severity of the harm varies based off of the application. Somebody using ChatGPT in their house to generate a Batman script isn't going to kill someone with that, but somebody that is using an AI system that is biased in a healthcare setting might. But these are three main categories that I wanted to draw attention to. That is decision making. Again, very problematic if it's high risk or if people believe that the tool cannot be biased and so are not looking out for that. There's the fact that these tools function differently for and on different groups of people. Language is one of those major problems, but also this is where we get into like the toxicity screening problems, and also the fact that as these tools become ubiquitous in our culture and people are being expected to use them in their daily work and school life, if the tool does not work as well for you, if there are parts of your experience that it cannot comprehend, you are at a disadvantage relative to other people who are using this tool, who are kind of its target audience. And then this last one is the idea of downstream harms. The idea that if there is a problem in a foundation model, like an LLM, that is likely to get pushed out to other systems that get used for lots of other different purposes. So let's get into automated decision making. So here are a couple of examples of law, hiring, and education. AI and algorithms have been used in policing for quite a while now, and people keep pointing out that if they are trained on past arrest data, crime statistics, areas that are considered hot spots for crime, the systems learn historical patterns of racial profiling, and they learn certain neighborhoods and certain zip codes. They need more police on the streets, and it often aligns with demographic factors. And then also, when used as ways of predicting who gets bail and who doesn't and how much, those algorithms can end up following along historical bail disparities and just replicating those harms further. In terms of hiring, these are current models out on the market, 3.5 and 4 for ChatGPT. They are perceiving a higher degree of credibility and professionality based on the perceived race of candidates' names, which is taking us all the way back to 1982 here. And so this is a situation where I hope that no one out there is using ChatGPT to screen their job applicants for them, but I don't necessarily know if that's a realistic hope. But this is a bias that is baked into it. And then I gave an entire workshop about this last point over the summer. It's on our YouTube if you want to look at it. But detection tools that are used to spot students who are believed to have used AI text generators in academic dishonesty tend to be biased against students that are non-native English speakers, and they are not as good at detecting the output of models that students have paid for. So students using the free version are more likely to get caught. Students that are doing the best they can with a second or a third language are more likely to get caught. In the case of the first one, if another rich student is doing the same thing and cheating, it is not fair that the poorer student is more likely to get caught. And in the case of non-native English speakers, they might get caught whether they used AI at all. Getting into differing performance, there are translation errors that happen even if they have been given material to help them with translation. If their whole system was built on English, it's not like a bilingual speaker, like a human being. There is like a mechanized translation thing happening in a lot of cases. And it's already more difficult if you are a non-English speaker on the internet, because your internet experience was built for the most part by and for people in the United States and the United Kingdom who are English speakers. A lot of software like browsers don't have support for every language in the world or every type of script in the world. You might have to get a specialized keyboard if you want to type in another language that doesn't use Latin script. There are issues of misinformation and fake news spreading on social media in non-English languages because there isn't moderation support to catch it the way there is for English. And then for privacy and surveillance, if you're one of 1,000 speakers of your language that is using the internet and you are getting marketing cookies on your computer and you've got companies that are surveilling you to try to sell you things, it's much more likely that they're going to be able to identify you as an individual individual relative to somebody who is one of uncountable numbers of English speakers using the same tools. And so when we are getting into things like AI systems and algorithms becoming super ubiquitous, that is another situation where that's just one more hurdle that people have to go. Covert prejudice over users' dialects. This was a scary article. It started off talking about overt versus covert and implicit versus explicit bias, and talking about how ChatGPT 3.5 and 4 have been trained not to say overtly racist things anymore, but still produce decisions that were based on prejudice. Even if the content that they are producing about people is no longer negative, since they have gone in and fixed things in 3, they're still making these decisions. The researchers used the role play like aspect of ChatGPT to assign it the role of a judge in a criminal trial, and fed them transcripts of the hypothetical defendant's testimony and wrote it in standard American English versus African American English. There was a higher likelihood of harsher sentencing, guilty verdicts, and occasionally the death penalty based on dialect. And then finally, this last one, bias in determining toxicity. This is what we were talking about before. Demographic dialects are more likely to be read as toxic by the metrics used to detect that than standard American English. And they also often erase terms of self-identity that are used in a contextual standpoint by people in marginalized communities. And the example that I'm thinking of specifically for that last article that is cited there is the word twink, which is a term used by some gay men to self-identify. But because it is also a category of pornography, it was listed as part of the list of no-no words that were used to comb out problematic content from a data set that later went on to become the backbone for technologies like ChatGPT. It just depends on who is the one holding the ruler. And then finally, we've got downstream harms. We've got situations where if you have a foundation system that has bias in it, that can carry on to however it is being applied later. The example here is the idea that if you have a medical AI that is using a chatbot to allow healthcare practitioners to communicate with it, that's going to be based off of an LLM. And so again, these can be used to help label and describe data sets for future tools. And if these biases just kind of are replicated from iteration to iteration to iteration, they kind of become the standard, which, as identified by the National Institute of Standards and Technology, is a problem because it makes them more likely to codify that and continue that prejudice onwards. The researchers describe this as an algorithmic monoculture. The idea, like what happened with bananas back in the day, where every banana was exactly the same cultivar, and then a blight came through and we lost all of the banana crops. It's a sort of similar thing. If these machine learning systems have similar weaknesses, they have similar areas where they suffer in, that can end up being a big problem. And so finally, we've got this section here going forward. I again want to reiterate, I'm a librarian. What you're going to do is going to be entirely dependent on you, who you are, and where you are in your life. How you go forward if you are a developer for artificial intelligence systems is going to be very different than if you are somebody that's considering using them to help you write emails. If you are somebody who's wanting to develop AI systems, I really recommend that you read that National Institute of Standards and Technology standard that was released this summer. It goes into a great amount of detail about concrete ways to build better systems. But for the rest of us, one of the best things that we can do is stay informed and be selective. There are some situations where AI use is inappropriate or might have potential harms. And right now, it's up to all of us to kind of figure out what that is, where our line is. But you can't make an informed choice if you don't know what it is that you're using. So if you learn as much as you can about whatever tool it is that you're wanting to use and how you want to use it and how it was developed, that will give you a better idea of the potential risks. In the workplace, the consequences can end up getting a little bit more potentially risky, especially if you are somebody who's a nursing major or a criminal justice major. It's a good idea to know how AI and algorithms are being used, what circumstances they're being used on, if there are human checks to counterbalance them, or if it's just kind kind of the algorithm making the decisions unsupervised, and having a good idea of like what could go wrong if the algorithm makes the wrong choice. The idea that algorithmic bottlenecks in decision-making processes can be a huge problem, where if a machine is the only one deciding success or failure for something, maybe reworking that decision-making system so there are different points of failure or success, some of which are moderated by humans, or at least by different algorithms. And then if there is something that feels unfair, draw attention to it, because that is how it gets fixed. People in 1986 in that medical school in the UK, they brought it before their commission against racial discrimination and essentially put the algorithm on trial and gathered evidence and found that it was discriminating against prospective applicants. And so that is one of the ways that you can move forward, is to speak up. And then finally, I'm going to end on a bummer, and I'm very sorry about this. In the wider world, these tools are already in use by corporations, by government entities, by other individuals out in the wild, some of whom are using them for good, some of them are using them for ill. If you can stay informed about how these are being used, do so, although there's a lack of transparency in a lot of cases about what these algorithms are, how they're making their decisions, and how much human supervision there is. And also, people can always lie. There is the concept of fair washing, which is the idea that it is possible to build an AI or an algorithm that is biased on purpose, and then for the purposes of avoiding being sued, develop an algorithm whose job it is to come up with a fair sounding rationale for why it did this that does not touch on issues of bias and has completely benign characteristics, even when the system was deliberately intended to be prejudiced. And so that's super sad. And I am sorry that it ends like that, but it is definitely something that we all have to be aware of, because this is the world that we live in. I'm going to scroll through my citations, and I'm going to try to not do it so fast that it makes people dizzy. If you have any questions, please feel free to reach out to me. I am always happy to talk to people about this, either one-on-one or with your class. I think that one of the most important things that we as an institution can do is make sure that this is not a topic that is sidelined, and to keep as informed about it as possible. I've also created a text-only version of this that is a little bit more screen reader friendly than the slide deck, that has all of the citations. Both of those are linked in the video description. But I really appreciate all of you taking the time to come and attend this today. This is very much a surface level brush over of the topic, and there were lots of places I wish I could have gone in greater depth. I just want to say thank you all, and I hope you have a wonderful day. Take care.